Okay, so we're back and we are doing lesson 9 from chapter 5, and it says, Guess my parallelogram. This is the last section of our chapter. So we'll be going over this and making sure that you guys are ready for your test, which is on Wednesday. So it says lesson 9, Guess my parallelogram. So in this lesson, you'll be able to classify and justify types of parallelograms based on characteristics of their angles and diagonals. Can I classify parallelograms as squares, rectangles, hold on a second, squares, rectangles, rhombuses based on a few given characteristic properties, such as characteristics about consecutive angles or characteristics about their diagonals? Okay. So it says Kia and Kamalani, maybe, are playing a guessing game in which one person describes some of the features of a parallelogram, and they have that they have drawn, and the other person has to name the type of parallelogram, either a square, a rectangle, or a rhombus. Here are some of the clues that they gave each other. Decide which type of parallelogram they are describing and how you know this. So first of all, we need to go over what a square, a rectangle, and a rhombus are. Okay, so what's a square? What makes a square a square? So what makes a square a square? Hold on a second. Sorry, I'm just trying to fix my thing here. There it goes. All right. All right, so a square, like some of you said, so square, rectangle, and rhombus. So I'm going to define these for you. You guys said something about 4. So someone said 4 sides. So yes, they have 4 sides. Anybody know what a 4-sided figure is called? Anybody know what a 4-sided figure is called? Yeah, it's called a quadrilateral. Quadrilateral. Why would it be called that? Why would they name it a quadrilateral? Quadrilateral. Yeah, exactly. For those of you who've been on a quad before, maybe I haven't been on a quad ever. A quad means 4. It actually, the prefix, the term, I don't know if it's a term or prefix, but it actually means it's 4 sides or 4, right? So there's a quad at the big high school, and the quad is called a quad because it has 4 sides. It's not a square. I don't even think it's a rectangle necessarily, right? Very good. And then, so we have a couple of other different reasons for why you all think that's so. Very good. So, so all of these are quadrilaterals. I agree with you. Okay, so they all have 4 sides. Someone says a rhombus has all equal sides. That's exactly the definition of a rhombus. So the definition of a rhombus is a quadrilateral. I'm going to put 4-sided, or 4 sides. That all sides are, I'm going to put the word congruent. I'm going to put that word congruent. So a rhombus is a quadrilateral with all 4 sides congruent. Very good. Okay. What would make a rectangle or a square a square? What makes a rectangle or a square a square? What makes a rectangle or a square a square? Oh, yes. There you go. A rectangle does not have 3 sides. What's that called? What's that 3-sided figure called? Yeah, it's called a triangle. So a square, very good. So a square has all, so again, it's a quad with all sides congruent and all angles congruent, meaning it's a 90-degree angles, right? Yeah, tri means three. Very good. Very good. You guys all comfortable so far? Really good. Okay, what makes a rectangle then? What makes a rectangle a rectangle? What makes a rectangle a rectangle? Yeah, that's all. It's a quad that has four right angles, or if you want to say four congruent angles, that works too. Whatever you want to talk about. Everybody okay with that? Okay. So you should all know what the pictures of those looks like because you guys have seen them since you were probably in first and second grade, maybe even sooner. So it says the diagonals of this parallelogram are perpendicular to each other. The diagonals of this one are perpendicular to each other. Who could this be? Could it be a square? Could it be a rectangle? Could it be a rhombus? So let me see if I can draw pictures. I can. Okay, here's a rectangle. Let me try drawing it over here. So there's my rectangle. And then here's my square. And then here's my rhombus. Okay, so which one of these do you think have diagonals that are perpendicular to each other? Yep. You think the square? Yeah, so try drawing that out and seeing if that makes sense. Yeah, try drawing that out. Draw the diagonals and see if that makes sense, right? So does this diagonal look perpendicular to that one? Does it look like it's perpendicular? Okay. And what about this one? Does this one look perpendicular to this one? And does this one look perpendicular to this one? Which one's a no? For sure, no. No. Which one's a no for sure? Yeah. For sure, the no is going to be this guy. Like, no way. There's no way that those two look perpendicular. This one, I think I could, if I drew this better. Oops, I didn't mean to do that. Hold on. Let me try erasing better. So if I drew this one better, I think I can get this. I think that one's better. What did I do? Oh, I know what I did. There you go. All right, let me try drawing this guy again. All right, what do you think? Yes or no? I think yes to the square. What do you think about the rhombus? Yes or no? It's actually a yes. So this one's yes and yes. Okay. So let me draw some more shapes for the next one. You guys figure out the next one. It says consecutive angles. What does the word consecutive mean again? Who remembers what consecutive mean again? No, in math. That's what we're talking about. Nope, not opposite. No. Do you guys don't know what consecutive means? So on consecutive days, do we have this class? On consecutive days, do we have this class? No. Consecutive means this, like Monday, Tuesday, right? Are those 2 days consecutive back to back? Do we have those? Okay. Thank you for letting me know, hon. Yeah. So Monday and Tuesday would be consecutive days. So give me a number that's consecutive to 3. Give me a number that's consecutive to 3. 4. Oh, we're on Desmos. I just take notes out of OneNote. It's just easier. Yours should match that. Yes, ma'am. Yeah, it's close to. It's next, right? So if I said, I need you to wear black on consecutive days, it means on Monday you're wearing black, on Tuesday you're wearing black, right? So that's consecutive. Are you guys comfortable with consecutive? So in terms of angles, if I said I want you to look at this angle right here, who's consecutive to that angle? Yeah, the one right next to it. Either this one or this one. Consecutive angles are the ones that are right next to it. Okay. So they're saying this says consecutive angles of this parallelogram are supplementary, meaning they add up to 180, right? So which ones of these add up to 180? Yeah, very good. So someone said, when I think about 180, I think about a straight line. Very good. So which ones are these? So square, rhombus, or rectangle? What do you guys think? Which ones of these have consecutive angles that add up to 180? And if you're trying to get better for your test, then you're saying, oh, it makes sense because. Should we go one at a time? All right, square. Yes or no? One person says yes. Okay, now why? If you say yes, yeah, that's exactly why. That's exactly why. So do you guys think about it? What do you guys think? Why would so the square answer is yes. Why do you think yes? This is what one of your classmates says. Yeah, because 90 plus 90 is 180, right? Because you guys all said that these angles here are 90 degrees. And what's 90 plus 90? Very good. Very, very good. Very good. Okay. Moving on. What about the rhombus? What about the rhombus? Yes or no? Do you think the rhombus's consecutive angles are supplementary? Do you think the rhombus's angles, do you think they're supplementary? What does this look like? Anybody see what this looks like? What does this shape look like? What do you see in this shape? In the rhombus? We're on the rhombus. Okay, I see two triangles. What else do you notice about the big, like the shape? I get why you're saying it's kind of like a square. Very good. And that's kind of true because all four sides are congruent. I notice that these two sides look parallel. And these two sides look parallel, right? Right? And what did we learn about this angle here? And if I extend it this way, right? What did I learn about these two angles? I'll call it angle 1 and angle 2. What did we learn about angle 1 and angle 2? Anybody remember what those are called? No? We can look back. Where would it be? This one? I think it's here. I don't remember. No, not there. I don't. Yeah. Remember? What is it called? Angle 3 and angle 6. What are angle 3 and angle 6 called? Yeah, very good. Alternate interior angles. And what do you know about them if those lines are parallel? If those lines are parallel, what do you know about angle 3 and angle 6? They're congruent. So say this again with me. It says along the bottom. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. Then alternate interior angles are congruent. So that, to me, I could actually use another one of those, but I'm not going to because I just like this one better. So if angle 1 is congruent to angle 2, tell me about angle 3. What do you know about angle 3? If angle 1 is congruent to angle 2, what do you know about angle 3? What do you guys see? Yes, they're on the same line. Very good. And what does that mean? What does that mean if they're on the same line? What do they add up to? Very good. Oh my gosh. Oh my gosh. I got to write this down. Hold on. Hold on, people. I got to write this down. Very good. So you're saying that which two angles add up to 180 because they make a line? Which two angles add up to 180? Very good. So we would write measure of angle 2 plus measure of angle 3 equals 180. So we're going to do a little proof here because we have proofs on the test, right? What did you just tell me about measure of angle 1 and measure of angle 2? What did you just tell me about measure of angle 1 and measure of angle 2? They're what? What do you know about measure of angle 1 and measure of angle 2? Based on this last example, where were we? Here? Yeah, what did we know about those two angles? What do you know about those alternate interior angles? Yes, they're congruent, right? They're congruent. So I know that angle 1 is congruent to angle 2. If I know that they're congruent, what can you tell me about their measures? What can you tell me about their measures? If the angles are congruent, then the measures are what? Equal. Very good. You don't have to write this on the test. It's okay if you just put, it's okay if this one right here you neglect. It's okay. Right? Because you just told me that measure of angle 1 and measure of angle 2 are equal. Do you guys remember that? Because they're alternate interior angles. Does anybody see my next logical step? So look at this whole picture. We have measure of angle 1 plus measure of angle 3 equals 180. Oops, I didn't want to do yellow, sorry. We have measure of angle 1 plus measure of angle 3 is 180. And then we have measure of angle 1 and measure of angle 2. And the question they're asking, are the consecutive angles supplementary? So they want me to prove that those two angles are supplementary. Which two angles are supplementary? What do they want me to prove? Which two angles are they trying to get me to prove are supplementary? It's okay to be wrong here. Be wrong so you can be right on the test. Be wrong so you can learn it. Nope, not those ones. In the rhombus, they want consecutive angles. Do you remember what we said about consecutive? On consecutive days, you guys need to be wearing black, right? So which two angles are they talking about? Now ignore everybody else except for the rhombus. Like erase everything that I wrote. Yeah, back to back. So which two angles are we talking about? Yes, very good. So you want me to prove that angle 1 and angle 3. What does supplementary mean again? Very good. Add up to 180. Man, I wish I had an equation that said that. I wish I had an equation that said that. What would you write next? Now look at what we have down. Measure of angle 2 plus measure of angle 3 equals 180. Measure of angle 1 equals measure of angle 2. What would you now do? Yes, why can you write this? Someone wrote this in the chat. I will share it with you. Someone wrote this in the chat as the next line. Why can they write that? Why can they write that? Does anybody see why they can write that? Yeah, that's right. So I'm going to write this out for you so you guys can see it. Do you guys see how measure of angle 1 is the same as measure of angle 2? So instead of me writing measure of angle 2 plus measure of angle 3, I'm going to write what instead of measure of angle 2? What did we use? What did we write instead of measure of angle 2? What is that called when I put something in place of something else? What is it called when I put something in place of something else? Yeah, substitution. Very good. I see some of you are like super ready. I'm very excited about this. So let's work on our reasons. That's substitution. How come we can write measure of angle 1 equals measure of angle 2? I'll condense these for now. Later on, we'll separate them out. Why? What was the reasoning behind angle 1 and angle 2 being congruent? What was the reasoning behind angle 1 and angle 2 being congruent? Scroll back in the chat. Very good. AIA theorem. Very good. Give me 1 second, guys. So what's the first reason? Why did we how come we can write measure of angle 2 plus measure of angle 3 equals 180? How come we can write that? Why did you guys say that we could write that? Because you guys are the ones who said it. I didn't say it. Oh, someone asks, how come I didn't label the top? Because I didn't need it. These are just people in the background. They're my backup act or my background actors. What are they? Extras. That's what they're called. These are just extras, meaning I don't need to label them. Yeah. So why can we write this? Is it legit that we can write this? Measure of angle 2 plus measure of angle 3. I need you to look at those two angles. Be a detective right now. Can you? Was it right for us to write these down? Because if we can't, then all of this whole proof is, like a deck of cards. It just fell over. So why can I write measure of angle 2 plus measure of angle 3 equals 180? Two is subtracted. No. You guys scroll through your chat. You guys said it. This is the advantage of our class, right? Everything that was said is literally being documented for us. Scroll back. Oh, there. I see someone said it. Someone said it. If you're looking for the time, someone said it at 1:10, but they said it privately to me. Oh, but someone else said it. A different person said it, and they said it at 1:09. Yeah. Did you guys get it? No, substitution belongs at the bottom. That's for sure. Can you guys look at 2 and 3? What are 2 and 3? What's so special about 2 and 3? Come on, guys. You can do this. What is so special about 2 and 3? Why do they add up to 180? Yes, because they make a line. They make a line. So we can call this linear pair. Oops. Linear pair. Okay, it's a linear pair, meaning they form a what word do you see that? Does anybody see what word is in linear pair? Yeah, it's a line. So whenever you see a line and you have angles, two angles making up that line, you're going to say linear pair. So be comfortable with these things. Get used to seeing them. Say, oh, when I see this, it means this. When I see this, it means this. Whenever I see a lot of substitution here, like, for example, measure of angle 2 plus measure of angle 3 equals 180, and then measure of angle 1 equals measure of angle 2, I bet you I'm going to do substitution. Okay? So recognize that when you form a line, it's gonna be linear pair. Everybody okay with that? So this one's a yes too, Miss Johnson? Yeah. Square is a yes. Rhombus is a yes. What about rectangles? Do rectangles have consecutive angles of this that make a parallelogram? Yes or no? Just put it out there. Let's just be brave. And then if you say yes, why? If not, why not? I'm getting some people answering. I'm not getting everybody. You guys all okay? Getting some, not everybody. Yeah, very good. Very good. So some of you are moving forward. Some of you are moving forward. So they just want to know, is this angle here, I'm going to call it angle 5, and this angle here, angle 6, do those add up to 180? Do you think those add up to 180? So I got a bunch of yeses. The answer is yes. Now why? The answer is yes. Why? No. Well, I guess so. If you took it and you like, someone said because they make a line. Yeah, if you cut this, sure, I'll take this. If I cut this angle out of a piece of paper and I lined it up and I lined it up over here, right? This is me like tearing paper and lining them up next to each other, right? I took this corner and I put it over there. Yeah, they make a line. But why else? Yeah, because the angles add up to 108. Wait, how do you know? How much what degrees is this? Measure of angle 5 equals to what? How many degrees is measure of angle 5? How many degrees is measure of angle 5? Very good. How did you know that? How did you know it was 90? That's right. How did your classmate know that that was 90 degrees? Like, who told him that? Yes, because that's the definition of a rectangle. That's what we came up with over here, right? A rectangle has 4 right or congruent angles, or they're all 90 degrees. So are you saying that 90 plus 90 is 180? Yes. Hey, Ms. Johnson, all 3 of them are yeses? Yep, all 3 of them are yeses. Questions on this? Very good. All right, I'm going to have you guys try this one on your own. The diagonals of this parallelogram. Oh, did you know that? Did you know that all 3 of these are parallelograms? All 3 of these are parallelograms. So you guys should know that. So I'm going to have you guys check this one. It says the diagonals are congruent. Are all of these diagonals congruent? So you do that, and I'm going to put up here that these are parallelograms. And so do you guys remember all the things that you get if you know that something's a parallelogram? Do you guys remember this? I'm going to change these definitions to being a parallelogram. This is going to be the same word. If you don't remember, anybody remember where I can find really quickly where my properties of a parallelogram are? Someone remember? I'll give you a hint. It's on this notebook. Where is it? Yeah, it's up here. Very good. So up here in the theorems, definition, and postulates, the very first page of this section, we have down here are your parallelogram definition or properties. So opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. So some of you are actually adding 2 here, and you can actually add what we just did to that. So let's see. We could add that the diagonals are perpendicular for who? Who are the diagonals perpendicular for? My OneNote just froze. There it goes. Oh, wait, looking at this picture, we just did this. Which ones of these, square, rhombus, or rectangle, which ones of these have diagonals that are perpendicular? Yeah, which ones are checked, guys? Yeah, square and rhombus. Very good. According to this, what did you guys just prove on this one? Yeah, consecutive angles are supplementary. Very good. Okay. So you can add all those things. Okay, now you guys are going to try this one. Diagonals of a parallelogram are congruent. So first draw them in and see if you guys can get it. Okay. Go ahead and do that. So if you look at the diagonals, I can actually prove that the squares ones are congruent. So for the person who said square, awesome job. Yes, you're right. Right? I can measure that. Okay. Does this look longer or shorter than this? Does this one, this diagonal, oops, I'll change colors. Does the black one look longer or shorter than the pink one? Does the black one look longer or shorter than the pink one? Yeah, it looks longer. So this one's a no. Right? What about the rectangle? Does the black one look longer than the pink one? Does the black one look longer than the pink one? Oh, so do you think they look like the same size? Yeah, because they are. Very good. So this is a yes and a yes. Quick proofs. Okay. These are quick proofs. I'm going to look at the yellow triangle. You guys all see my yellow triangle? This is going to be the same proof for both the rectangle and the square. Okay. I'm going to look at the yellow one versus the blue one. You guys all see my blue triangle? Everybody see that? Okay. So, how would I prove that those two triangles are the same? How can you prove that those two triangles are the same? Do they look the same? Yeah, very good. Someone said by reflection. Kind of. Not exactly, but I know exactly what you're talking about. Very, very exciting. Very good. So, that's exactly right. So, yes, like folding it up and matching it. That's exactly right. So, if you understood that part, then you're good. So, can you imagine that I just wanted to compare these triangles? And so the easiest way to prove that triangles are congruent is by using like one of those things. But like, do you all agree that this side here, this side here is congruent to this side here? You guys all see that? Yeah, because like you fold it and those two sides are congruent. Does everybody see that? If you take the 3 seconds to imagine that, does everybody see why that works? Okay. And then can you all agree with me that this bottom side is exactly the same? Yeah. Does everybody see how that bottom side is exactly the same? Yeah. And so there's one more piece that I probably need to like show you. So this angle of the yellow guy and this angle of the blue guy are exactly the same. So we haven't really gotten into triangle congruence yet. That's what we're going to get into next chapter. But here I basically prove that those two triangles are congruent. But you guys can intuitively know that based on reflection, folding, that kind of thing. Okay. Why does the bottom have 2 lines but the sides only has 1? Anybody know why the bottom has 2 but the sides have 1? I mean, I guess I could actually have this being 1 as well, because I could fold it up like on a square. I could fold it up, but I was trying to do it generically for my rectangle over here, right? So very good. Very good. Okay, let's do this next one. When rotated 90 degrees, so what does that mean? Like I pick up my square and I rotate it 90 degrees. I pick it up and I turn it. Does that make sense? Each of these parallelograms gets superimposed on top of each other. So if I had 2 copies of this square, okay, if I had 2 copies of this square and I rotated it 90 degrees, meaning I went like this corner is going to this corner, and this corner is going to this corner, and so on and so forth. Would they line up? Would the square line up? Yes or no? Yes, very good. Yeah, this is a yes. Okay, let's try a different one. What about for the rhombus? would it line up? Would the second one line up on top of the first one? Would the second one line up on the first one? Yeah, this one's a no. Something's in my eye. Okay, figure out the rectangle. Ouch. So did you guys figure this one out? Did the rectangle line up? What do you guys think? Yes or no? Yeah, the answer is no for this one. Yeah, and if you don't know why, it would technically go like this or something. I don't know. This is a bad drawing, but this one would, you know, this one would go here. Right? Yeah, that's how it would go. It would actually go like that, as opposed to going all the way across, right? So yeah, this one's definitely a no. Very good. Okay. So we already said this word consecutive, right? So consecutive angles are not supplementary but are congruent. So they want to know, are the consecutive angles congruent? What does consecutive mean now? Again, what does consecutive mean? Yeah, next to. So is this guy congruent to this guy? For a square, for a rhombus, for a rectangle, what do you think? Who is yes and who is no? Square, someone said yes. How come? Yeah, the square is a yes, but why? What are all the angles in a square? Yeah, they're 90 degrees. Actually, that's their definition, remember? The definition of a square is all angles are congruent. So if all the angles are congruent, right? Are the ones right next to each other congruent? Yes. Okay, what about a rhombus? Yes or no? Rhombus, yes or no? Does this guy look congruent to that guy? Do those two look congruent? Yeah, this is a no. That was easy, right? I don't even have to think about it. That one, no, that doesn't even look like it. Ms. Johnson, you said we can't go based on that. Yes, you are right. But you can use your intuition to figure things out. What about this one? Rectangle, yes or no? Rectangle, yes or no? Yeah, rectangle is a yes. Again, because all angles are congruent. Okay, we are going to finish off by going over our takeaways, and then I'm going to let you work on some homework, and then that's it. So here's your takeaways. It says, today we proved the following theorems and properties of the diagonals of different types of parallelograms. Okay, so here are some of the different, oh, I'm going to type them because I can type faster than I can. Right, give me 1 second. So I'm going to type them, and then I want to copy them to that other page, but maybe, I don't know, we'll see. Oh, there it is. Okay. Okay, so what were the ones that we figured out about parallelograms? What did we figure about? This is about the diagonals. What did we figure out about the diagonals of a rhombus? Let's see. So look at the rhombus. This is about diagonals right here. What did you figure about the diagonals? Very good. They're perpendicular. Very good. So the diagonals of a rhombus are perpendicular. Okay. What else did we learn? Who else's diagonals are perpendicular besides the rhombus? Look at this picture. Yeah, very good. Square. Okay. So then let me write that down. You guys aren't seeing this, but at the very bottom, I'm typing out, and I'll show you in a second, but I just want to get this down here. So the diagonals of a square are perpendicular. Here. Okay, let's see what else. What else do you know about the diagonals? Let's see. That's not diagonals. That's not diagonal. Oh, here. What's this one about? The diagonals are who? Whose diagonals are congruent? Whose diagonals are congruent? Very good. The squares. Very good. And no, not the rhombus. Look careful. Yes, the square and the rectangle. Okay, so the diagonals of a rectangle are congruent. And then, so instead of me typing that all out again for square, notice here are perpendicular and congruent. Oh, that's pretty cool, Miss Johnson. How come the square gets everything? Well, because the square is so, and I know this sounds funny, but the square is it's regular, right? So because it's regular, the sides are the same, the angles are congruent. You get all this really good information. Okay. We also proved the following theorem about parallelograms in general. Okay. Which one was true for all of them? No, not that one. No, not that one. Which one was true for all of them? I'm trying to get you to see all 5 of them at the same time. Which one was true for all of them? Yeah, number 2. Oh, okay. So that's true for all parallelograms. All parallelograms have consecutive angles that are supplementary. Oh, okay. So let me write that down here. Consecutive angles that are supplementary. All parallelograms have consecutive angles are supplementary. Oh, sorry, this is coming out a little funny here. I'm just going to scoot it over. You guys get what I'm talking about. And then the last one was, based on today's lesson, I have some additional strategies to think about proofs. Okay. So thinking about proofs, some of you came up with them today, right? Some of you noticed that there was a line, and whenever you have angles, that means linear proofs. Some of you noticed that we can have reflections. Some of you noticed that even within our other proofs, we still had some of that other stuff. Like, for example, this one. This keeps, I don't know if about you guys, but I keep seeing substitution over and over again. I keep seeing linear pair over and over again. I keep seeing the alternate interior angles. Okay. So there's these chunks of proofs that you'll see over and over again. Does that make sense? Okay. So with that, I'm going to have you guys start. I'm going to make you guys look at your exit ticket. This is actually really good. This is where I'm going to have you guys work on today, as well as one of the problems before we go. So it says, complete this chart for the types of parallelograms based solely on the information about their diagonals. Start by completing these sentence frames. I know a parallelogram is a rhombus if the diagonals are what? I know a parallelogram is a rhombus if the diagonals are what? Okay, so let's look at our little chart table here. So I used to draw this chart all the time for my students. We have parallelograms here, and then we have rhombuses and rectangles, and we have squares. Okay, so this is kind of like a weird inheritance tree, right? So just remember that, look at the flow, it goes down. So everything that a parallelogram is gave it to rectangles, which then gave it to squares. Everything that a parallelogram is, rhombuses inherited that information, and so did the squares from that. So squares get everything because squares is a very particular type of rectangle and rhombus. I remember I was tutoring this little third grader, and he was so cute because he said something like diagonal, or he said something about rectangles, and I said, well, is a square a rectangle? And he goes, no. And I said, why not? And he goes, because a rectangle has longer sides. It's like a smushed square. And I said, okay, well, what makes a rectangle a rectangle? And he said that all the angles are like corners. And I said, good. Does a square have angles that are like a corner? And he's like, yeah. So I want you to know that every square is a rectangle, but is every rectangle a square? Do you understand my question? I'm going to say it again. Every square is a rectangle. Do you guys all see that? Good. Is every rectangle a square? Good. No. Ms. Johnson, what do you mean every square is a rectangle? I mean that if I came in here, hold on, let me get my drawings out. It's easier for me to draw than it is for me. It's easier for me to draw in here than it is for me to put this out there. So I'm going to draw you a shape, and you tell me what it is. Tell me all the names that we can name this thing. Uh-oh, I moved something. Look, I moved this. I did not want to move you. You need to go back over there. Sorry. Yeah, we can call it a square. Good. What else can we call this thing? We can call it a square. Good. What else can we call it? Yes. Very good. Someone put it all. Oh my gosh. Someone put all these names. I got to copy this. Hold on. Copy this. Give me a second. This is exactly what I was looking for. There's one more name that you can actually call it. Hold on. Let me get it on here. Someone said we can call it all these names. Someone said I can call it a square. Can you really call this thing a square? Yes, Miss Johnson. Can you really call this thing a rectangle? Yes, Miss Johnson. Can we call it a rhombus? Yes. Can we call it a quadrilateral? Yes. There's one more name that we can call it. Yeah, we can also call it a parallelogram. Very good. So, but we will call it a square because that is the most specific name that we can call it. But do you see how a square is also a rectangle, is also a rhombus, is also a quadrilateral, is also a parallelogram? Does everybody see that? Okay. So I'm going to let you guys fill this out on your own. But now if you look at our homework, you can, well, this is review. So looking at our set problems, right? You can now do these. I'm just going to tell you right now, if you can do 6, 7, and 8, I think you're ready for your test. Okay. So I'm going to stop recording. Great job.